Hey guys, this is Tony over at Cantina Creative. Today I wanted to jump into PFtrack, show you guys a little demo. I'm going to go through it pretty quickly, so just hang in there. And what I wanted to utilize is some of the LiDAR looks and techniques that we used in Furious 7. This will be a good opportunity to just go through the application, run through some user tracks, auto tracks, camera solves, and do some tests, objects, and export it. So, hang in there with me. I'm going to go through this quite fast, but I think that you'll get the idea and the concept behind it. This essentially is what we're playing out here is our LiDAR look. We're gonna match move this, bring this into C4D and build the geo for it. Once we get all the geo built, we will be able to come up with this particle system that lays onto this geo, which is pretty cool, doing that in After Effects. So this is the PFtrack version here, and let's just jump right into PFtrack now. So once we get into PFtrack, we're gonna bring in our footage here. For this show, the plates we were using were all shot on the Alexa. So we're dealing with 4x3 plates that are 2880 by 2160. So I'm gonna ignore the tree over here on the left. I'm gonna build it out and build out a new one here. So let's always just make sure our pixel aspect ratio is proper. It should be set to 1. Sometimes PFtrack will bring it in kind of funky. So I'm gonna build out a custom pixel aspect ratio. Let's set that to 1. If it's anamorphic, it's gonna be 2. It's really kind of all you need to know for right now. And in order to reference this film back, I usually create a little template here that I can go into based on these 4x3 plates that the Alexa shoots. I know what my film back is, so I can type that in, the 2376, which will get us locked into 17.82, and I can double check. So we're good with our film back. We're starting off nice. I'm gonna save this preset here, and I've already saved it out. It's my Alexa 4x3 preset. Let's get started with an auto track. It's a good place to set. This is really not that complicated of a scene, so the auto track will be able to get us, but there's some reflections, there's some scaffolding, there's moving cars, so we're gonna have to mask all of that out. As you can see, I've masked a lot of that out, but I wanna show you how to make a mask as well. You can see I'm doing reflections and cars, and I don't wanna complicate this auto tracker. So let's build our own mask here with our Bezier Roto. We're gonna just grab this little section of this scaffolding. There's some lights in there that are kind of maybe distracting. And right here, you can see you can auto track this. It will track it for you like in Mocha, how Mocha does that. But I'm gonna just make these, I'm gonna set these auto keyframes. I'm gonna set these keyframes myself. It is set up to auto, so as you can see, I'm just dragging this by, having out these keyframes and making my own. And this is gonna be a real rough garbage mat that's just gonna block this area out here. I don't like this first keyframe, it kind of scales weird, so I'm gonna show you how to delete this keyframe up here in the beginning. Just cruise right into here, remove it, and you can set a new one here, and it will just auto keyframe it for you, which is really nice. So we can scrub through this and see that we're covering up this section, and we've got our masks all kind of squared away and set. So we can set our featured scale to large, just keep it on better speed for right now, but there's some cool things you can do there. And you got some deformations as well that are pretty handy to use as well. I'm gonna up my candidate number and my target number here, and I'm gonna set this failure threshold. I'm gonna set that up as well as this minimum length. I like to set that up a little bit higher, especially for a shot like this. So let's set our candidate number and our target number. Let's increase that so we've got some good data to build out this camera track with. So we're gonna fire off this auto track, and I can already see this auto track has got some messy, squirrely little guys out there that we're gonna go hunt down now. So this is just better than us running a user track on everything. This is this auto tracker that's gonna help us grab these tracks. So let's hunt down these guys right here that are just terrible. I just want to straight up delete these guys. So we're gonna just delete these kind of squirrely guys out here, and try to look for some others that are just should not be in our scene. We just want to get rid of this whole guy. But there is a way, if you do find some squirrely guys that work for you, like this guy may work towards the end of it, but may not work in the beginning. So we'll find the area. Everything before this is just a mess, but we're going to keep everything else. So we've got that set up, and I don't want to mess up this camera solve. So this is really just eyeballing, and I'm flying through this right now, you guys. Hang with me. We're going to set up a user track, and we're going to set up maybe 3 user tracks. I'll show you how to do that. We'll just create a user track. I'm going to grab the corner here. I know this is not really a good spot to try to track because there's not a lot of contour or contrast. Everything is looking very similar. I'm going to set up some deformations here with the skew, rotation, and scale, and I'll move also into our failure threshold. This illumination here that I just checked, it's good for reflections, sun moving, things like that. I like to click that nighttime scene, and as I start to track here, I can already see that this is just not a good spot to track. So let's find ourselves a better spot to track, usually the window, something with some contour and contrast. So we'll slip it down here to the window, and we'll go ahead and manually kind of get through this area, and then we can just fire it off. It's looking pretty good. I can see a few areas that need to be redone because it sees the window, it sees another window, and it thinks that's what it's supposed to track. So I'm gonna find the area where it bounces, and I'm just gonna manually just go 1 frame forward here, which sets frame here, and that allows it to kind of get through those kind of rocky spots there. So I'm holding its hand, but it's doing a lot of the work itself. So I feel like we can probably fire off. Yeah, here we go. No sweat. It's picking this up. It's not bouncing around. So the rest of this is all good. So we've got our first user track here, and we can grab some stuff in the foreground using the same concept. I'm not even going to change any of these values. Well, let's go ahead and change these values. Let's up these again. Let's get this one up to a 9, and it looks like this is going to lock on, and this guy here is going to lock on. And the failure threshold essentially is just saying I want something that's really, really good. The lower we go, we're saying we don't need it to be as good, and it will fail. So 0.85, 0.9 gets us something pretty good there. And let's get something in the background. What happens if we don't have a user track that works throughout the whole shot like I'm showing you? What is if we have a user track back here that I'll get it into a bad spot here where I'll kind of force it to track through some areas where the building's going to cover it up here. So you can see I'm still tracking here, but this is not good. This is going to mess up your camera track right through here. So how do we get rid of these keyframes that are set? It's pretty simple. We'll go back to something that works, and then we'll just say everything here, let's get rid of, let's just get rid of these keyframes here. So bam, these keyframes are gone, and now we just want to hide that user track so it's not floating up there by itself. So we're just going to go ahead down here to the right. We're going to go ahead and just say hide everything here, and now we've got this guy set back there. One of the reasons I like to set things back in the background and the foreground is it gives you some good parallax when you're trying to do your camera solves. So I've got 3 user tracks, I've got an auto track, and I want to just basically solve all of these together with our camera solver node. We'll bring this in. Sometimes you may know that lens, but for this case, let's just leave it unknown for right now. So we'll do this solve and we'll see what we get. We get ourselves our first little point cloud here, and we got our ground plane that's kind of a little wonky. So first thing I usually like to do here is just orient this scene so that we can kind of look at it a little bit better and see what's going on. So we'll get our orient node, and we'll go ahead and kind of line this up the best I can. There are better ways to do this. There are some really nice ways to kind of get a good orient scene, and but for right now, I kind of know that I can just bang through this really quickly, and this is really simple without getting too complicated and using too many lenses to estimate focal length and all that. So we're in a good spot, and I'm just kind of showing you here how to move these things around, and we don't need this target track. I'm gonna go ahead and delete this. You can see how I'm deleting this, and let's instead here, let's go ahead and let's do some test objects. Let's grab a mushroom, port that into our scene. We can we can really just pick a selected feature and line that up, and we can orient this as well in any axis that we'd like to. And we can duplicate this and just throw one up on the building. And no PFtrack solve is good without a cow head. So let's get this cow head in there. Let's orient this cow head. And not only can you rotate, but you can also scale it. You can also, translate it as well. So we'll darken this background here, which is a nice little feature. And we'll play this track. Let's hide this ground plane. And we can kind of see now what we're dealing with a little bit better looking at these test objects. I'm looking at this point cloud and I can see that we got points floating around, and that's going to mess up our camera solve. So what I'm going to attempt to do now is basically hunt down these floating points that are problematic in our camera solve, and then I'm going to refine our existing camera solve. So in the error tab here, we can see the individual 3D points that have veered off course. We want to deactivate these solved points so they no longer feed spatial data for the camera solve. You can see that they're climbing really high in this graph, and I found that anything over a threshold of about 2 can really become problematic. Those problem trackers can alter your camera solve and give you inaccuracies. So I want to first show you this method, and then we can go over the trim feature. Yeah, you can just start clicking on, you can grab a bunch of these. We don't need this guy, we don't need this guy. This guy's pretty cool, but he's kind of looking at me strange. So we're gonna go ahead and get rid of these and just deactivate these. And this is gonna help our refine when we do our refine. Okay, there's still a few points out there that are a little bit bizarre, but we don't really, let's get rid of this guy here, deactivate. So we don't really need to get rid of all of them for right now for what we're doing. I'm just kind of trying to fly through this, give you the concept of it, and then you can meticulously go through your own point cloud and see what's out there, what's kind of bouncing around, because there could be some bogeys out there. You're always gonna have to hunt down those bogeys. You're gonna grab that marquee tool and you can select whatever it is you need to select. So let's talk about trim now. So what trim does essentially is it's going to basically set this threshold that says anything above this, don't calculate it into the camera solve. So I'm going to refine everything now, and I get a new and better, who doesn't want new and better? So we're going to get a new and better camera solve here. We can see these test objects are a little bit more locked in. I see points floating around, but I'm gonna just kind of go with what I got because this is looking pretty good for the most part. But like I said, I want to go back in and go back into our orient node here. We're gonna turn off the darken button, and what we've got now is we've got our scene. And what I want to do here is essentially take 2 points and get some kind of real world scale to this. So we kind of need to have a little bit of a eyeball this, and looking at these trusses here on the side, these scaffolds, maybe if each one of these is like 10 feet, we could probably kind of rough this in at around 80 feet. Looks like an 80-foot putt to me, so I don't know, maybe we'll go with 80 feet, which gives us a rough ballpark here. It's going to reset this whole scene to real world scale, and that's going to be pretty helpful once we go into C4D and start modeling the geometry. And the next thing we really all we really need to do now is just export this scene. So we're going to go ahead back into our grab our export null, and we're going to set up an export. This is going to be pretty simple, but one of the cool things here that some people kind of skip, you can actually indeed just exclude some of the points in these big clouds. Let's take a few points here that maybe we don't want to bring in, and we'll go ahead and select these and exclude them from our export. So I'm not going to really be modeling any geometry way back in here. I don't need this necessarily in my export, but I did need it in my camera solve. Those are the differences here. So we're just literally taking away nulls that would be transferred over. In this case, why I do that is to try to stay a little organized, try to have a little bit lighter export. And if I'm going into After Effects, sometimes all I really need is just an isolated area. In this case, I'm going to be taking this into C4D. So I'm just going to pull a few of these out as an example of, and like I said, you can take out a ton of this when you do your export, which makes it light and it's pretty easy. So this looks pretty good for right now. I'm going to bring all this point cloud in. Let's get rid of these guys back here. I'm not going to really be modeling geometry back here. So you get the basis of that. Using the NewTek Lightwave export setting here, this will allow us to really just open up this file right in C4D. You can see that there is no C4D export, so this does the trick perfectly. So save it out, bring it into C4D, then start modeling your geo. You got your camera track, and we're all set to go. Thanks for hanging in there with me. I know we kind of jammed through this demo really quick, but I hope you guys just get an idea of what you can do. PFtrack is a powerful match move program. This right here is just one of the apps used for our Furious 7 LiDAR look, and the next one will be with C4D that I'll run through, and then into After Effects we'll go in depth with the particle system and rendering all that out. Again, this is Tony with Cantina Creative. I hope this helps guide and inspire you in developing your own creative vision.